everyone, I'm Abhishek and today I will talk about polynomials and its related terms. The first question is, what is called polynomial? So it is an expression of the form an x to the power n plus an minus 1 x to the power n minus 1 plus so on a2x square plus a1x plus a0, where an minus 1, an minus 2 and so on a2, a1, a0 are the real numbers and n is a non-negative integer, then the expression like this is called a polynomial in variable x. Here x is called the variable and an minus 1, a2, a1, a0 are called the coefficients, and there will be many more coefficients in this continuation. A polynomial is usually denoted by fx, gx, hx, px, qx or rx, etc. So therefore we can write a polynomial fx as an x to the power n, an minus 1 x to the power n minus 1, n minus 2 x to the power n minus 2 and so on a2x square plus a1x plus a0. So here x is the variable. Now here all this marked with red pen are called terms, and this term is called the term of x to the power n, where an is the coefficient of x to the power n. This term is called the term of x to the power n minus 1, where an minus 1 is called the coefficient of x to the power n minus 1. Similarly, this term is called the term of x to the power n minus 2, and an minus 2 is called the coefficient of x to the power n minus 2. This term is called the term of x, and a1 is the coefficient of x. Now up to this, all the terms are called the variable terms, because with each and every terms a variable is involved. But in this term there is no variable, or we can say that a0 is multiplied with x to the power 0, so that is why there is no variable. So therefore this term is called the constant term. Now we call this term as a leading term, and the coefficient involved with this leading term, that is an, is called the leading coefficient, and this n, that is the exponent of the variable x, is called the degree of the polynomial. So we can write for this polynomial degree of fx is n. Now let us see some examples. So our first example is 2x to the power 5 minus 3x to the power 4 plus 5x cube minus 2x plus 1. So let us see what we can derive from this polynomial. First of all, how many terms are there? So the answer is it has 5 terms, and these are 2x to the power 5 minus 3x to the power 4, 5x cube minus 2x and 1. Now the next question is, what is the coefficient of x to the power 5? And the answer is, the coefficient of x to the power 5 is 2. Similarly, we can ask, what is the coefficient of x to the power 4? Let's see what can be your answer. What? Did you say 3? Then I'm sorry, that will be a wrong answer. The coefficient of x to the power 4 is minus 3. You have to involve the negative sign also. And similarly, we can say that the coefficient of x cube is 5, coefficient of x is minus 2, and the constant term is 1. But wait, where is the term x square? Is it vanished, or is it there? If it is there, then what is the coefficient of x square? The answer is, the coefficient of x square is 0. So that is why if you multiply 0 with anything, it will give 0. So that is why the coefficient of x square, the term x square is not there. Hence we can say here, since the term x square is not there, That is why the coefficient of x square is 0. Now the next question is, what is the degree of this polynomial? Yes, this is the leading term. And what is the exponent of the variable of this leading term? It is 5. So therefore we can say that the degree of this polynomial is 5. Now let us see some more examples. Our second example, x to the power 100 minus x to the power 50. So this is a polynomial of degree 100. Now the question is, what is the coefficient of x to the power 100? The answer is 1. What is the coefficient of x to the power 80? The answer will be 0, since there is no terms in between x to the power 100 to x to the power 50. Then what is the coefficient of x to the power 50? The answer will be minus 1, since there is a negative sign before x to the power 50. What is the constant term of this polynomial? The answer will be 0. And how many terms this polynomial has? The second polynomial has only 2 terms. One is x to the power 100 and the other one is minus x to the power 50. Let us see this third example. Root 2x square minus root 3x plus 6. So it is a polynomial of 3 terms, where the terms are root 2x square, first term, the second term is minus root 3x, and the third term is 6. And the degree of this polynomial is 2. Now our next example is 2. Wait, what? 2? Is it a polynomial? You might be thinking like this. Let me clarify this. This is a polynomial of one term. It has some names. We can call this as rather monomial, since it has only one term. Monomial. Mono means one. Poly means many. So we can call it as polynomial of one term, or we can call it as a monomial, the fourth example. Or we can call this polynomial as constant polynomial. Why constant polynomial? Because it has only the constant term. It's better to call it a constant polynomial rather than monomial, because if I talk about the polynomial x to the power 5, this is also a monomial because it has only one term. So it's better to call the fourth example, the polynomial, as a constant polynomial. Then what is the degree of this polynomial? The degree of this polynomial is 0. But how the degree of this polynomial becomes 0? We can write 2 as 2 into x to the power 0. It has only one term and hence it has only one leading term. This will be the leading term. And the exponent of the variable of this leading term is 0. That is why the degree of this polynomial is 0. Now our next example is 0. It is a 0 polynomial. We call this polynomial as 0 polynomial. Now the question is, what is the difference between 0 polynomial and a constant polynomial? Since we know that 0 is also a constant number. Yes, we can call it a constant polynomial, but see, for every value of x, it is coming 0. That is why it is called 0 polynomial. And also, the important thing is the degree of the 0 polynomial. The degree of the 0 polynomial is, don't say it's 0, it's undefined. Now we will learn about polynomials of various degrees. The first one is polynomial of degree 0, which is known as a constant polynomial. For example, 2, 3, minus 2, etc. But don't write here 0, because 0 is not a constant, it's rather 0 polynomial. 0, though 0 is a constant number, but we will call it as 0 polynomial. The degree of a 0 polynomial is not defined. But here, for the constant polynomial, the degree of a constant polynomial is 0. Now the second one is a polynomial of degree 1, which is known as a linear polynomial. For example, 2x plus 3, 4x minus 5, x, etc. The general form of a linear polynomial is ax plus b. Here a should not be equals to 0. Now the third one is a polynomial of degree 2, which is known as a quadratic polynomial. For example, x square plus x plus 1, 2x square minus 3, minus x square, etc. The general form of a quadratic equation is ax square plus bx plus c. Here a should not be equals to 0. Similarly, degree 3 polynomial is known as a cubic polynomial, and degree 4 polynomial is known as a biquadratic polynomial. The examples of cubic polynomial is x cube minus 1, 2x cube, minus x square plus x minus 1. And the general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a should not be equals to 0. And these are the examples of biquadratic polynomial. And the general form of biquadratic polynomial is ax to the power 4 plus bx cube plus cx square plus dx plus e, where a should not be equals to 0. Now, according to the number of terms, we call the polynomials as monomial if it has only one term, binomial if it has two terms, trinomial if it has three terms, and so on. Now we can see some examples of monomial, binomial and trinomial. Like the examples of monomial are x cube, 2 or 4x or minus 3x to the power 100. So these are all single term polynomial. Now this is not depending on the degree. The degree can be anything. If there is only one term, then the polynomial is known as monomial. Similarly, the examples of binomials can be x to the power 100 minus x to the power 50, 3x plus 2, like this. Similarly, we can understand for trinomial there will be three terms. Now we will talk about equality of two polynomials. Now let fx and gx be two polynomials, where fx equals to an x to the power n plus an minus 1 x to the power n minus 1 and so on, a2x square plus a1x plus a0, and gx equals to bmx to the power m, bm minus 1 x to the power m minus 1, and so on, b2x square plus b1x plus b0. Then fx and gx are said to be equal if number 1, degree of fx should be equals to degree of gx, that is n equals to m, and number 2, if ai and bi are equal. Since here n is equals to m, so therefore bm will be considered as bn, so therefore a0 equals to b0, a1 should be equals to b1, a2 should be equals to b2, and similarly an should be equals to bn. Now next we will learn about the value of a polynomial. Suppose fx is a polynomial. The normal form of polynomial an x to the power n plus an minus 1 x to the power n minus 1 and so on, a2x square plus a1x plus a0. Then f of c, which is the value of the polynomial fx at x equals to c, we will replace x by c. For example, suppose fx equals to 2x square plus x plus 1, then the value of fx at x equals to 1, which is denoted by f of 1, is 2 into 1 square plus 1 plus 1. So here we have put we will put x equals to 1 in place of in the variable x, so therefore it will be 2 into 1 square plus 1 plus 1. So for example, fx equals to 2x square plus x plus 1, here the value of fx at x equals to 1 will be denoted by f of 1, we will just put x equals to 1 in the expression. So it will become 2 into 1 square plus 1 plus 1, which is equals to 4. Now let us find out f of x equals to x cube minus x square plus x minus 6. Let us find out the value of fx at x equals to 2, which is f of 2, and this is equals to 2 cube minus 2 square plus 2 minus 6, and the value will be 8 minus 4 plus 2 minus 6, and which is equals to 0. Now we can say that for the second function, for the second polynomial fx, the value of fx at x equals to 2 becomes 0. So therefore x equals to 2 is known as 0 of the polynomial. So what is the meaning of 0 of a polynomial? And the definition of a 0 of a polynomial is if px is a polynomial and if p of alpha equals to 0, that is the value of px at x equals to alpha becomes 0, then alpha is called the 0 of the polynomial px. Hence, what is the difference between 0 of a polynomial and 0 polynomial? 0 polynomial is always 0. For any value of x, 0 polynomial is 0. The value of 0 polynomial is always 0. But 0 of a polynomial means for some polynomial, if for some value of x, if we get the value of the polynomial 0, then those values of x is called 0 of the polynomial. Now the next one is what is called polynomial equation. Polynomial equation means whenever we equate a polynomial with any other number, it can be 0, it can be any other number also, then it is called a polynomial equation. Like an x to the power n plus an minus 1 x to the power n minus 1 plus so on, a2x square plus a1x plus a0 equals to 0 is a polynomial equation. Now here we can write any other number also, but in that case that number will come to the left hand side and it will make the equation in this form. Now if x equals to alpha satisfies this equation, then the value alpha is called the root of this equation. Therefore if we consider the polynomial as px, and if for x equals to alpha, p alpha is coming 0, then alpha is called the root of the polynomial equation px equals to 0. Therefore roots of a polynomial equation and the zeros of the polynomial are same. So for example, if x equals to 2x square plus x plus 1, here the value of fx at x equals to 1 will be denoted by f of 1. We will just put x equals to 1 in the expression. So it will become 2 into 1 square plus 1 plus 1, which is equals to 4. Now let us find out f of x equals to x cube minus x square plus x minus 6. Let us find out the value of fx at x equals to 2, which is f of 2, and this is equals to 2 cube minus 2 square plus 2 minus 6, and the value will be 8 minus 4 plus 2 minus 6, and which is equals to 0. Now we can say that for this second function, for the second polynomial fx, the value of fx at x equals to 2 becomes 0. So therefore x equals to 2 is known as 0 of the polynomial. So what is the meaning of 0 of a polynomial? And the definition of a 0 of a polynomial is if px is a polynomial and if p of alpha equals to 0, that is the value of px at x equals to alpha becomes 0, then alpha is called the 0 of the polynomial px. Hence, what is the difference between 0 of a polynomial and 0 polynomial? 0 polynomial is always 0. For any value of x, 0 polynomial is 0. The value of 0 polynomial is always 0. But 0 of a polynomial means for some polynomial, if for some value of x, if we get the value of the polynomial 0, then those values of x is called 0 of the polynomial. Now the next one is what is called polynomial equation. Polynomial equation means whenever we equate a polynomial with any other number, it can be 0, it can be any other number also, then it is called a polynomial equation. Like an x to the power n plus an minus 1 x to the power n minus 1 plus so on, a2x square plus a1x plus a0 equals to 0 is a polynomial equation. Now here we can write any other number also, but in that case that number will come to the left hand side and it will make the equation in this form. Now if x equals to alpha satisfies this equation, then the value alpha is called the root of this equation. Therefore, if we consider the polynomial as px, and if for x equals to alpha, p alpha is coming 0, then alpha is called the root of the polynomial equation px equals to 0. Therefore, roots of a polynomial equation and the zeros of the polynomial are same. Now next we will learn how to divide a polynomial by another polynomial. Let us see by an example. And the example is divide 2x cube minus 7x plus 3 by x square minus 1. So here this is the dividend and we will write this polynomial here. But since the term x square was not there, we should mention this as 2x cube plus 0 into x square minus 7x plus 3. And this is the divisor and we should write this here. And since the term x is not there, we need to write x square plus 0 into x minus 1. Now here the leading term is x square and here the leading term is 2x cube. So to get to x cube, we need to multiply 2x here. So we should write 2x in the quotient part and we'll multiply 2x with each and every terms of the divisor. Now after multiplying 2x, we get this polynomial. Now we will subtract the polynomials. So after subtracting, we can see the 2x cube terms are cancelled out. Hence, we get minus 5x plus 3. Now to get minus 5x, we need to multiply here with minus 5 by x. Then we should write here minus 5 by x. But if we write minus 5 by x, this quotient will not be a polynomial. Hence, if we get the degree of this polynomial less than the degree of this polynomial, then we should stop the division and this polynomial is called the remainder polynomial. This is called the quotient polynomial. Now let us talk about the division algorithm for polynomials. So it is given that if a polynomial fx is divided by a non-zero polynomial gx, then there exist unique polynomials qx and rx such that fx equals to gx into qx plus rx, where rx is either a zero polynomial or degree of rx should be less than degree of gx. Here f is called the dividend, gx is called the divisor, qx is called the quotient polynomial and rx is called the remainder polynomial. So this was the division algorithm for polynomials. Now in my next video I will talk about two more important theorems, that is remainder theorem and the factor theorem. Thank you.